Hey, it's Bradley from Bradley Gore Blog. Today I'd like to take a look at the NativeScript Repeater once again and take a look at how we could implement actions that are hidden beneath the view that shows the data for the items that you're looking at. For instance, if you wanted to have an edit and a delete button that sits behind the item's primary view and you slide that over to the left or to the right to reveal those buttons, there's a pretty easy way to do that. And so we're going to look at that, and let's start with our file structure. So if you look here in the app folder, what I've got is just a standard set of basic files like what you'd have if you created a project based off of one of the templates. Actually, the template I typically use is the Hello World TypeScript template. And I've just removed the view model, and so I'm left with the main page.ts, the main page.xml, app.ts, and app.css. So the most complicated part of doing a repeater with swipe to reveal actions is actually in the view. The code is actually pretty simple. So let's start with the view and let's work through it and see how we're going to approach this. The view is pretty standard starting out. We have a page with a navigating to event, and we have it pointing to a navigating to function in our JavaScript file. We have a stack layout as kind of the primary layout for our page, and it's just going to lay things out vertically, one on top of the other. A label that's going to be the title, so we give it a class of title, and we have our repeater. So the repeater is going to take a list of items, and for every item it runs into, it's going to use the item template that we feed it, and it's going to get a copy of that template and inflate it and put it in the view for our item. In this case, I'm feeding it a list of people. The item template here is actually going to use an absolute layout. This is pretty important because what we actually want is we want items to sit on top of each other along the z-axis versus stacking one on top of each other along the x or y axis. If you've ever used an HTML element and set its positioning to absolute and had to set its top, left, right, or bottom manually, then this will be pretty familiar to you because that's exactly what this absolute layout does. Everything starts at the 0, 0 XY coordinate. So we have two layouts that we're going to use inside of it. One's a grid, one's a stack. Both of those are going to start off at the 0, 0 XY coordinate, but the order in which they appear along the z-axis is going to be the order in which you lay them out. So the grid layout is going to be first, and on top of that is going to show up this stack layout. So the grid layout's actually going to contain the hidden action items, and it's also going to contain a divider. So we're going to give it a class of action so that we can use some CSS to style it, and we're going to have to set the rows and the columns. Now, if you've worked with absolute layout stuff before, either in NativeScript or absolutely positioned items in the HTML, then these items really need kind of specifics on what you want them to look like. They don't typically just work exactly how you want. You've got to give it some details. I need you to be this tall, this wide, this coordinate for your top, this offset for your left, that type of thing. So you've got to do the same thing here. So we're going to tell it that the rows, we're going to have two rows, and the first one's going to be 60 units tall, and the second one is going to be auto. Whatever it needs to be, just put it in there. Then we're also going to specify the columns. The columns are going to be 80 units wide. Then the second column is going to be star. So if you've seen other posts of mine or the previous video I did on the repeater, where I've talked about the grid layout, the star is basically just saying once you calculate the other columns and what they need, I want all the space that's left. And you can also do other things like where a column would be 2 star and the other column would be 1 star, and then it does some different calculations. But for this case, we're basically just saying I want everything that I can possibly have for this column. And then the third column is again going to be 80 units. So if you kind of picture a screen where on the far left you would have a delete button or an edit button in this case, and on the far right you'd have the delete button. That's what we're implementing here. So we're going to have these three labels, and these are going to be the first row, and these are going to be our three columns along that first row. The first label, its column is 0, its row is 0. Give it a text of edit, a CSS class so that we can style it, and we're going to wire up a tap event. The second label actually has no text. It doesn't need to, it's just a filler. So we're just going to tell it it's the column at index 1, and it's still in the first row, which is index 0, and it's the one that's going to get this star width that's just taking up everything that it can take up after the other two get whatever space they need. And then finally we have the last label, which is in the third column, or index 2, still in that first row, so it is going to get a width of 80 units. We're going to give it some text of delete, a CSS class so we can style it, and then a tap event. Now the second row is going to take up whatever vertical space, so rows is for vertical space, columns is for width. It's going to take up whatever vertical space it needs, and it's the second row, so its row index is 1. But it's going to take up all three columns. So if you've worked with HTML before and worked with tables and you've seen call span before, you'll probably know already that it essentially just tells the element how many columns it takes up. So if we had 5 columns and we said that something took up 3 columns, there'd be 2 columns left on that row that something else could take up. In this case, we're telling it 3 columns, and that is all of the columns available. So it's going to go from all the way at the left to all the way at the right, the full width. And we're going to give it a CSS class. And it doesn't have any content, it doesn't need to. There's not really, in NativeScript, there's not really a horizontal rule element like there is in HTML, so you could use a label or a stack layout, either one, doesn't really matter. So now we're going to take a look at the foreground. The foreground is going to be a stack layout because we just want to lay items out vertically. In this case, it could have been a grid layout, it could have been just a label. I mean, it really doesn't matter. It just needs to be something that you can give it a class and add this pan event. So in our case, it's a stack layout because I have 2 labels. Every person that is passed into the list has a name and a position, and we want to display those. And we have this event wired up for the pan. Pan event is just whenever a person puts their finger down somewhere on the screen and drags their finger around from some starting point to some ending point and lets their finger up. That's a pan event. Alright, and that is the end of the template. So let's take a look real quick at the CSS, because there's a couple things that we have to specify in the CSS since we're using these absolute layouts. So you'll see I've got some general things like the title is going to be a big font, it's going to horizontally line itself in the center, it's going to have some margin, but alongside all of these other things about, with like background colors, there's a couple things that are really important to notice. First is that inside of a repeater element, we have an element with a class of actions. That is the grid layout, that is the background for each item in the repeater. You'll notice that it has this class of actions, and we're giving it a width of 100%. So because these items are absolutely laid out, they are not kind of going to lay out how they would normally. They're going to just take up whatever space that they would need. So if you want it to take up the whole width, you're going to have to tell it to take up the whole width. So that's what we've done here. And again, we have some general classes for the edit action. It's going to have a dark green color. For the delete, it's going to have a dark red. So all this is just pretty generic stuff. But then we get back to inside the repeater element, we have an item with a class of info. Now that is the overlay or the foreground for the item's view. And so that's got a class of info, and again, we want it to take up the full width. But for this one, because this is not a grid layout, we didn't have the opportunity to specify how tall it needs to be. So if you look at the background item or element, it is a grid layout, and we passed in to the rows 60, auto, which means the first row is 60 high, the second row is just whatever it needs to be, it's auto. On the stack layout, you've got to use styles or CSS to do that. So we want it to be the same height as that row. Now we do not want it to be as high as both rows in the grid layout in the background, because that would cover up the divider. And we also wouldn't want to put the divider in the foreground, because if you went to swipe it left or right, the divider would move along with it and you would see where it ends and where it begins. So it's best to have it in the background. For the divider, if you see here, we have the repeater element and then an element inside that has a class of divider. We're giving it a height of 2. So because this grid layout knows it's got 2 rows, and it knows that the second row should just have an auto height, then it's only going to give this second row, this divider, the height that it needs, which is 2. So let's take a look at the JavaScript file, or the TypeScript file. And the first thing that we want to look at are the imports, because there's a couple different things that we're importing here that maybe you've not worked with before, but are really important when doing this type of view and functionality. So the common ones are the first 4. We have the event data from the observable module. Most events are going to implement this event data interface. Whether it's the loading event, the unloading event, the navigating to event, tap events, like all kind of different events implement this interface. So this is pretty common to use. Observable array, most of your lists are going to use an observable array. And this is pan gesture event data. And pan gesture event data is essentially an interface that extends the event data. So it has the normal things that an event data has. For instance, it has the object property, which is the reference to the view that this event is getting fired on. It also has some other properties, which we'll look at in a little bit, that are really handy when doing this absolute layout and positioning the sliding type of overlay on top of some actions in the background. Another thing that the UI gestures module has is this gesture state types. A great thing about the pan event is that you can look into the pan gesture event data and you can see a state property, and that state property is going to correlate to this enum that is gesture state types. So we can know with extreme precision when did the pan event start, if it's still going, or if the user ended it. And that's really important to know. So let's look at the navigating to function real quick. So when somebody navigates to this page, we're going to get a standard event data, our standard set of arguments that implements the event data interface. And we're going to just get a reference to the page. So args.object is the view. In this case, it's fired on our page element. And so it's a page. And we're going to set its binding context. The binding context is going to work for the entire page, and we're going to apply to the entire page. And it's simply an object with a people property. The people property is just a new observable array. Each person has 2 properties, a name and a position. So we've got Billy the Kid, he's an outlaw. We've got Wyatt Earp, who's a lawman. And we have Doc Holliday, who is your Huckleberry. The next functions that I want to take a look at are actually the edit and the delete. When an edit person event is fired, what has happened is the label has been tapped. The label inside the background, the grid layout here. And so if you notice, the item is inside of our repeater.item template, and so it's going to have a binding context. But the binding context is not going to be the page's binding context, or even the binding context of the repeater, or the items of the repeater, which is the whole list of people. Every item in the repeater is going to be bound to the corresponding item in the actual list. So you're going to get a reference to the person that was tapped whenever you look at this view's binding context. So what we're going to do in the edit person function is we're going to get that event data. Again, most events adhere to that interface, or to some interface that has extended that interface. So arg.object, it's a type of view. We could have totally imported the label module and cast it as a type of label, but we don't really need that that level of specificity. So I'm just going to tell TypeScript it's a view, and we're going to grab its binding context, which is the person that was bound to that item. But we also want the whole person list. Fortunately, any view instance has a page property, which is the getter to the entire page. Now, if we recall, the page has a binding context, and we set it to an object with a people property, and so we can just reference it that way. We get a handle for the page, binding context.people. And so that is that observable array. Then we want to get the index of the person to edit, and that is the person list.indexOf. Now, if you recall from previous video or previous blog posts where I've talked about the observable array, you'll know that the observable array implements almost all of the methods and properties that the normal JavaScript array implements. So we can totally just take this observable array, use .indexOf, and pass in a reference to an item, and it will tell us the index of that item. If the item is in there, we will get a positive number, otherwise we'll get a -1. So in this case, we're just going to do a console log. And so we're just going to print out here, we're going to say we're going to edit the item number, and we're going to pass in the item's name. So every person has a name property and a position property. We're just going to print out the name property. Then once you've got that going, the delete is no different. You actually do the exact same things because you have the exact same type of argument being passed in. You retrieve the data context or the binding context of the view exactly the same way. You retrieve your person list the same way. So pretty simple. So what about when we want to pan the items? In panning the items, we have to kind of think about how our background is laid out. We have those 3 columns, one on the left, one on the right, and then the one in the middle stretches across as much as it can. But we specified specific numbers, 80. So the button on the left or the button on the right, they're both 80 units wide. So that'll give us a starting point as to how much can we pan this item, how much can we slide this item left or right. When in terms of the overlay, how much can it go? So from that information, we can set some constants here. We can set a minimum x and a maximum x, because when we're panning the item, we're simply just going to be moving it along the x-axis. We're not going to change its y-axis. We're not going to change anything else. We're just going to slide it across the x-axis. So the minimum is going to be -80, because remember, all of them start at 0, 0, and the maximum is going to be +80. We're also going to go ahead and set up a threshold. Threshold is going to act as basically a cutoff point that says if you've reached this far and you stop, we're going to assume that you wanted to go the rest of the way, and we're going to take you there. So if you were sliding it to the left and you went 46 units, that is at or above our threshold. So instead of the overlay just standing there in some awkward position that may still be covering up half the button, then we're going to actually just go ahead and move it the rest of the way for the user. And that just provides a nice user experience. So let's take a look at how we can actually do that. The first thing that we're going to notice is instead of getting event data, we're actually going to get a pan gesture event data, which is the interface that this argument is going to implement. Because there's a couple additional properties on this argument that would not exist on a standard event data object. So we're going to get a handle to the view. So the overlay view is what was panned. So the arg.object that's passed in is the overlay view. And then we're going to get this new x. So if you're panning an item, if you're sliding left or to the right while you're panning, the entire goal is to move this foreground or this overlay to a new x position. And so that's what we're going to declare here is this new x variable. It's a number, and it's going to be the current translate x of the overlay view plus the arg's delta x. So if you've already been panning for a bit, and maybe you've already moved it 10 units to the left, your current translate x is going to be -10. Now arg.delta x is going to tell us how far you've moved total. So if you have started panning anywhere on the item, and then you touch down and you slide over to the left, it's going to tell us that you have panned maybe 10 units, or maybe -10 units, because it's going to start 0 is wherever you touch down. Instead of going off of 0 being at the normal 0, which is to the left of the screen, it's going to call 0 wherever you touched your finger down. That way you can get just the delta, just the difference, the amount that you've actually moved. And that makes it really easy to work with this. and to calculate how far left you can go or you have gone already. Now we need to check against our mins and our maxes. So if our new x is greater than or equal to our minimum x, and it's less than or equal to our maximum x. So if it is between the two, the min and the max, including the min and the max, then we're going to just set the overlay view's translate x to that new x. So if you have pulled it over and you're at 78, that is within bounds, or you're at negative 78, that is within bounds. And so we're going to go ahead and just slide the view along with your finger. Now here's the really important part. You can do all of this up to this point, but then if your user lets off at that 78, then you have your view kind of moved to kind of an awkward position where it could still be covering up some of the information that is being shown by swiping it to the left or to the right. So you need to check to see if the arg.state, which is again that pane gesture event data, has a property that a normal event data won't have, and it's called the state. And it tells you whether it started, in progress, or whether it's ended. So we'll take a look here at this gesture state types. Dot afterwards, we can see the different values. There's began, there's canceled, there's changed, which changed just means it's in progress, or it's ended. So if it's ended, and we're not already at our min or our max, then what we want to do is we want to use that threshold. We want to calculate where was the user going. Are they far enough along that we want to go ahead and finish that transition? If not, then we'll pull them back to the 0 or pull them back to the min x or the max x, wherever they started from. So we're going to default the destination x to 0 because that's going to be kind of the most common place you're going to go to. But then we're going to check if the new x is less than or equal to the min x times the threshold, which in this case is 0.5, it's a half. Then we're going to go ahead and just finish you off and send you to the min x. Else, if where you're at, where you stopped, is greater than or equal to the max x times the threshold, which again is half. If you're halfway there or greater, then we're going to go ahead and finish you off to the max x. And NativeScript has excellent animation baked right into its view components. And so we can just say overlay view.animate, pass in this little animation definition object, tell it to translate the x to the destination, the y to 0, because again we're not moving this up or down, we're only moving this left or right, and tell it to take 200 milliseconds to do so, and then we're done. So let's take a look at what that looks like. What I've got is I've got an emulator pulled up, and I have my console running. So I've got my people. I've got Billy the Kid, who's an outlaw, Wyatt Earp, the lawman, Doc Holliday, who is your Huckleberry. And what I want to do is I want to just start pulling these items. So if you can see, I pulled it, and then it finished the open. So I'm going to pull it just a little bit. I'm less than halfway. I'm going to let off, and then it closed it for me. And then I'm going to go more than halfway, but I'm still covering up half the word edit. But it knew that I was past the threshold, and it's going to go ahead and finish that transition for me. And so I'm going to click the edit, and you can see it's got the correct item. So I'll keep clicking on it, and then I'll go and we'll go to delete. And it's going to do the same thing. Clicked it a couple times. Doc Holliday. It's got the right item number. It's got the right name. All of this is just working perfectly. And there you have it. That's how you can do swipe to reveal actions in your NativeScript repeaters. I hope this has helped, and I hope you've enjoyed the video. Please stay tuned for there's more to come. Thanks.